All right, folks, let's do number 40. Uh, Vector E has a magnitude of 17.0 centimeters and is directed at 27 degrees counterclockwise from the x-axis. Oh, that's a pretty nice one. Okay, so this is going to be the x-axis. I mean the y-axis. And it's only, so it's not going to be a z. Okay. All right, and they say that vector E has a magnitude of 17.0 centimeters. So that's going to be somewhere like this. So that's going to be 17.0 centimeters directed at 27 degrees orientation from counterclockwise. So that means it's going to pull up like that. Vector B, so let's write the components. So vector E, and I'm going to define the magnitude of E to be 17.0 centimeters. That way I can just write this off as E cosine of 27 degrees E sine of 27 degrees. All right, so that's just that vector. Oh, well, okay. Well, I guess we're almost done. All right, so for this one, so they want to express this as the unit vector notation. So let's write that down. 17.0 centimeters cosine of 27 degrees. 17.0 centimeters sine of 27 degrees. I'm going to put this in the calculator. So 17.0 sine of 27 degrees. So this is going to be, so this is 15.15 centimeters, and this is going to be 7.72 centimeters. So if the question for part A wants us to express in the unit vector notation, that means we're going to put I hats and J hats. 15 centimeters in the I hat direction plus 7.72 centimeters in the J hat direction. So I guess that's part A, and we're done. Part B is going to ask, vector F has a magnitude of 17 point, let me just erase this picture here so we don't need this. I mean, you guys can draw this if you want, but I really don't want to anymore. So now vector V, I'm just going to write the components down at this point. Has a magnitude of 17.0 centimeters and is directed at 27 degrees counterclockwise from the y-axis. Oh my god, I guess I do need to draw this. Counterclockwise from the y-axis. They're both counterclockwise. So that's another way of saying 90 plus 27 degrees. So I'm just gonna write the end result. I'm not even gonna bother to draw this for you guys. I'm way too tired right now. So this is gonna be 17 centimeters cosine of 117 degrees, and I did add that to 90, so that should take account into the negative component because it's 27 from the y-axis counterclockwise in the I hat direction plus 17 centimeters sine of 117 degrees in the J hat direction. So I'm just going to put those in the calculator and write those components down. So once you write the components down, you should have negative 7.72, what is it, centimeters? Centimeters in the I hat direction. 17.0 sine of 117 degrees would be added to 15.15 centimeters in the J hat direction. So that's part B apparently. I love how these are so freaking random. Alright, vector C. G has a magnitude of 7. Oh my freaking god, it's the same thing. Oh well, I guess we're done. And this is blue, guys. Apparently people are retarded. Alright, vector G has a magnitude of 17 centimeters, and it's directed at and it's 27 degrees clockwise from the y-axis. So I'm going to take 90 degrees minus 27 degrees and call that 63 degrees. So I'm going to write this as 17.0 centimeters cosine of 63 degrees in the I hat direction plus 17.0 centimeters sine of 63 degrees in the j hat direction. So that means that G is going to be 17.0 cosine of 63 degrees, 7.72 centimeters in the I hat direction, 17 sine of 63 degrees, 15.15 centimeters in the j hat direction. I feel like I did this wrong, but I'm not entirely sure. But I think it's correct according to my logic. I mean, there's no reason. But let me see, actually, I have my answer sheet that I wrote pretty sloppy here. And it does match the answer sheet, negative point to positive and the positive and the positive. With the, okay, so I think the answer does match. All right. So the answer matches, guys. Beautiful. All right, goodbye.